I believe that in the teams that actually put machine learning in production, there should be also other skill sets that are even outside the realm of computer science. Then the important thing is, does the tool that I'm using support me in collaborating with people on understanding the model's performance? It's something that is becoming, in my mind, table stake.
Welcome to How AI Happens, a podcast where experts explain their work at the cutting edge of artificial intelligence. You'll hear from AI researchers, data scientists, and machine learning engineers as they get technical about the most exciting developments in their field and the challenges they're facing along the way. I'm your host, Rob Stevenson, and we're about to learn how AI happens. Here with me today on How AI Happens is a man who has all kinds of experience in our space. He was a staff research scientist at Stanford, as well as a staff research scientist at Uber AI. Currently, he is a CEO and co-founder over at Predibase. Piero Molino, welcome to the podcast. How the heck are you today?
Thank you very much, Rob, for having me. Really. It's going to be like a fun conversation. Looking forward to it.
Yeah, definitely. I've been looking forward to it all week because there's so much to go into. Firstly, I want to make sure I didn't totally brick your curriculum vitae there. Is there anything I left out as I was doing my intro?
There's a couple more things, but you got the most relevant ones. I would say, I also worked with a smaller startup called Geometric Intelligence in the past that was funded by a bunch of people, including Zubin Garamani, for instance, that then was acquired by Uber to become Uber AI, and also spent a little time at IBM Watson when I was doing question answering and at Yahoo before. So a couple more experiences, I guess.
Right. That is worth calling out that you were with Geometric until such a time as they were scooped up by Uber. And then that was the opportunity you were one of the founding engineers there for Uber AI. Is that correct?
Yeah. The team from Geometric Intelligence became the foundation team of Uber AI. And then we grew from basically about a 10 people team at the very beginning to a 100 people team by the end. So it was a fun ride.
If we had this recording 6 years ago, you probably couldn't tell me anything about it. But now, maybe you can. What was kind of your directive coming into Uber? And basically, they were like, "All right, now you Geometric Intelligence is now our AI department. Have at it." What were you intended to do there?
Right. Something's happening already at Uber when we joined. One thing that was already happening was the ATG team, which is the self-driving car team that then actually, I think in 2020 was sold to Aurora, if I remember correctly. But there was like a 1,000 people organization down in Pittsburgh mostly. And we were doing basically everything else, all sort of AI and machine learning applications and research. And specifically what I was working on was helping different product teams putting the latest and greatest machine learning research into production for specific use cases that were particularly important for Uber. I would say, in general, particularly important for Uber. Yeah.
Right. So it wasn't self-driving cars at the time. It was just sort of, can we operationalize AI for lots of different areas of the business?
Yes, absolutely. And I can give you some examples, for instance. Also, many of these were collected in engineering blog posts around the time, between 2017 and 2020, more or less. So if people want to double down on these topics, that there's plenty of resources there. So one of the interesting applications was customer support. So we put out this model that was called Dakota for supporting customer support representatives, for suggesting them the classification of the different tickets that were coming in, also what actions to take about them and how to respond to these requests. That was really, really useful. It reduces the time that representatives would take to answer to users and also improve the customer satisfaction. So it was a really nice application. Another one was the recommender system of Uber Eats, where I collaborated to create a new and improved version that was using more recent techniques, in particular graph neural networks. There was another project that was about fraud prediction, in particular detecting collusion between drivers and riders. And then another bigger one that I contributed to was this dialogue system for Uber drivers that allowed Uber drivers not to have to touch the phone while interacting with it on the ride, because there were some countries where that's actually illegal. And so we made it possible for the drivers to interact by voice.
Right. Illegal in some cases and dangerous in any case, truly, right?
Dangerous in any case, yeah, definitely. Yeah. But again, you would expect them to ideally stop and answer that. But if then their livelihood depends on clicking fast, then obviously that does not happen, right? And so it was very important to make it so that they could do it through voice without having to look at the phone or touch the phone.
Right, right. Let's incentivize these drivers to operate the phone safely anyway, right?
Exactly.
Yeah, makes sense. Piero, part of the reason I was excited to have you on is because you have spent time in academia as well in the private sector. And it's really common in this space, not guaranteed, but you come into it a good amount, having people with, one foot in either camp. So after Uber, you moved on to Stanford, where you were doing some research in ML and NLP. I want to have you reflect on the nature of why that is in our industry, why people do both. But first, I would just love to hear a little bit about your work at Stanford.
Yeah, so the work at Stanford was, I would say, maybe to do one step back, I got introduced to Professor Chris Ray from Stanford, with whom I worked when I was there. It happened in a really fun way, I would say. He did a public shout-out about Ludwig, which is an open source library that I put out while I was working at Uber, during an event that was recorded at Stanford about the future of machine learning infrastructure. And he was on a panel with Jeff Dean, and so he was commenting about this new library called Ludwig from Uber that was super cool. And so I reached out to him and we started chatting. He invited me to give a talk at his lab at Stanford. And it was like a really fun way to get to know each other, right? And then when my time at Uber ended, I decided, well, let's chat with Chris, because he also founded a bunch of other important startups in the machine learning space. Some of them were sold, some of them are unicorns now. And so he knows his way around. I decided to join him and say, well, let's think together what is the next step here. What can we do together as a next step? And so I worked in his lab and supported these students. We put out a couple of papers about, in particular, benchmarking, because I think it's a really important topic. But in the meantime, we were thinking about what we would do next. And so then the year after, we decided to start a company together to productionize these ideas about declarative machine learning that were already in my open source project Ludwig, but also in a project that he worked on while he was at Apple that was called Overton. We figured out that these things worked at Uber, worked in open source, worked at Apple, and so probably there was something valuable there to start a company about them.
Yeah, it's maybe worth spending some time with Ludwig. I feel like that name will ring a bell for some of the folks out there listening, but that kind of got you on Professor Ray's radar a little bit. And that was the seed from whence cometh Predibase. So for those who maybe it didn't ring a bell, would you mind sharing just high level what is Ludwig, and then we can get into how it became Predibase?
Yeah, absolutely. Super happy to talk about it. It's like a brainchild, right? So I'm always happy to talk about it. So basically, maybe to give like a little bit of context for Ludwig. So I was mentioning before some of these projects that I was working on when I was at Uber, right? And so what I noticed is that in all of these projects, there were many, many things that were in common among these projects, and a few things that would make them substantially different. Data and the schema of the data was one of the things that make them different, but pre-processing was the same for all of them. The training of the models was the same for all of them. The architectures were more or less the same for all of them. The evaluations were all the same, right? And so because I'm very lazy and I don't want to do something more than twice, the first time I need to do something, I usually try to automate it for myself and for my mental health, honestly. And because of that, I looked at all these projects. I said, what is in common among these? And I made it so that what was common became code and what was not common became a configuration. So in the end, what then became Ludwig was my own personal system, where instead of having to rewrite every single aspect of a machine learning project, and both the infrastructure and all of these aspects that I mentioned, I made it so that I could specify what was the scheme of the data and a few more details that I had control over, like, the training parameters, the specific architectures to use and things like that. And I wouldn't have to implement anything else. And so every new machine learning project, I had to write a 10-line configuration file instead of writing potentially thousands line of PyTorch or TensorFlow code. And then basically other people in the company, well, that first of all, that made it so that I could be substantially faster at starting a new project and getting to like good results very, very much faster than most other people at the company at the time. And so that caught the attention of other engineers, and they started to say, well, maybe if we could use the same tool, also we can be as effective as you are. And so more people started using it in the company. They were not applying it to the same task they was using it for, but to their own business cases, right? That convinced me that there was value there to release it as an open source project, because other people in the open source community would have benefited from it, hopefully. And also because it was built on top of open source technologies itself. So, it was a way to give back to the community to begin with, right? And so that was the motivation behind it. What it is now, it's really a project that is backed by the Linux Foundation. And the way it works is really you provide the data that you want to train your machine learning model on and a configuration file, and you get out like a trained model that you can serve by a single command and interact with it. And this configuration file is really easy to write, in particular to get started with. It's just one line for each feature that you have in your data and one line for each target that you have in your data and their data type. That's all you need to get started. But at the same time, there's more than 100 different parameters you can change and modify, including, again, architectures, pre-processing, training, optimizers. All these aspects are like just one string in a configuration file. There's more than 100, so you have full control over what you are training, right? And that's what the core of Ludwig is. And the reason why we call it declarative machine learning is because these configurations are declarative in nature. You're not telling imperatively what the set of operations or PyTorch commands. I would say you're not telling exactly the set of instructions, PyTorch instructions that you need to do in order to create and train the model, but you just declare the schema of your data and off you go, right? So it's much simpler.
Could you give an example of what declaring a schema of data would look like?
Yeah. So for instance, for giving an example, I was mentioning at the very beginning Kota, the customer support model. And so in that case, the dataset looked like a table with one column that was the actual text that the user would send. And then we had some additional information about the user, like for instance, if it was what app was it coming from? Was it coming from the Rider app, the driver app, or Uber Eats? And additional information about them, like how long ago did they join, for instance. Another thing that was there was information about the trip, if it was related to a trip, like how long was the trip, was it paid or not, was it canceled or not, and how expensive was it. And the goal was to predict what type of issue it was, what action among a set of possible actions to do to resolve this ticket, and also among a set of templates, which one to use to answer. And a Ludwig configuration for this task looks like it's a YAML file, and also you specify a list of input features, and this list contains one entry with the name, which is the name of the column in the data that contains the specific information, and the type. So for instance, in this case, request type text, source app type category, trip length type number, and so on, right? And then a list of output features where you say, well, they're basically the targets. And you can say, well, I want to predict a ticket type category, action type category, again, because there was a multiple set of them. And you could either generate the text, so you can say answer type text or answer type category if you have like a set of predefined answers, right? This is how the configuration looks like to begin with. And it's very simple. But then you can say also, I want to train it using, for instance, the text. I want to use BERT for encoding the text, or I want to use some other architecture. And I want to use it pre-trained, or I want to use not pre-trained. I want to fine-tune it. I don't want to fine-tune it. For the output, I want to use like cross-entropy loss, right? Or maybe I want to have a weighted cross-entropy loss that increases the weights for some classes. And so all these things, you can define them through the configuration. And then also training, you can say, I want to train for this number of epochs with this learning rate. And I want to use Adam V as optimizer because it's particularly good for fine-tuning of pre-trained models. And all of these aspects are just entries in this configuration file.
A minute ago, I wanted to call out quickly that when you were talking about developing it yourself, you shared what I think is the Occam's razor of software development, which is everything the same became code and everything different became configuration. And like, that's just every single software product, right?
Right.
It's a fantastically clean way of talking about it. So I wanted to call that out. I was tickled by that. But of course, Ludwig started as this open source project. And as with any good open source project, it starts as one thing, you open it up to the community, and it kind of blossoms into this other thing. So I'm curious, as you watched other people kind of put their fingerprints on it, were there ways the community used Ludwig that surprised you?
Yeah, so one thing that the project grew after I made it open source is that at the beginning, the supported data types were relatively more limited. Now there's many more. And there's, for instance, images, audio. There's also geospatial data can also be used. So there's many more things that I was not like directly adding at the very beginning because they were not used in my specific use cases. But I would say one thing that I'm proud of is the fact that the architecture is very extensible and it's really easy to plug and play new data types, for instance, or new models. So it's just, there are really lightweight wrappers and off you go, right? And so that made it possible for people to add their own stuff and also to use it in terms of applications for like applications that I was not even thinking about. a couple ones that are particularly interesting that, again, were really far from what I would have expected people to use the tool for. One was a research paper that actually was published on Science by a researcher from the Max Planck Institute that was using Ludwig for analyzing biological images of worms. And don't ask me more about it because I don't know the details of it. But I know that it was like, he was not like a machine learning person, not even a computer scientist. He was a biologist. And still, the configuration file was so simple as a mechanism that he was able to do something like this without being an expert, right? And so I'm proud of the fact that a tool like this enabled people to do machine learning that were not like machine learning experts.
Is that kind of an accidental effect of the declarative approach, or was that intentional? To put it in the hands of people who didn't have the technical background?
Right. So it was not very intentional in the sense that when I thought about it, I thought it for myself, for making my life easier, right? Then how easy it is, accidentally, it also makes it possible. I would say I wouldn't expect many people who are not developers at all to be comfortable with it. This specific person, this specific user was, and I was super happy about it, but it was not, I wouldn't expect it to be for most people. But I would say most developers that maybe are familiar with other configuration-based systems like, I don't know, Terraform for infrastructure, for instance, right? I think those kind of people definitely would be able to use Ludwig fruitfully. At the very least, to get started with, maybe they will not know the specific value that they should set for like the dropout layer of the first whatever layer in the network. But for sure, to get something out that works, they can definitely get that value out of the platform.
Certainly, yeah. So fast forwarding then, what role did Ludwig play in you founding Predibase? At what point did you realize, okay, I think we got something here. We should maybe incorporate around this activity?
Yeah. It was a combination of things. I would say, on the one hand, the positive reaction in the open source was already something that convinced me that it was, to begin with, something valuable, right? Beyond, because until you put stuff out, it's difficult to assess. In particular, if you're putting stuff out not as a product, but as like a project, right? That's how it started. Then the second piece was what I was mentioning before with Chris, the fact that there was someone really smart, who had a really similar idea to mine, and that we could do it together. That was really, really convincing. And then seeing also other companies building on top of this idea. Like, for instance, there's a system internal at Meta called Looper, and in their paper, they cite our work, for instance, and they describe a system that there are some differences, but in spirit and in approach, it's really, really similar to Ludwig 2. And so again, all of these things together, plus also having done some preliminary work and interviewing some of the heaviest Ludwig users and companies that were using Ludwig, all these things together convinced me that it was worth doubling down on it.
Gotcha. Just a piece of trivia, I'm curious. Why Ludwig? Why the name?
It's a secret, and I will never reveal it. I'm kidding.
It was your dog's name. Admit it.
No, really, it's a longer story. It's based on Ludwig Wittgenstein, which is a philosopher of the first half of the 20th century. And I have like a little presentation on YouTube where I basically connect what I believe are the dots between his work on structuralism and then work on, in particular, natural language processing and embeddings, and now then large language models. There's a fil rouge in my mind that connects all these things, right? And so because Ludwig, in particular, at the beginning was particularly focused on NLP tasks. It is still, but now there's also other modalities, but I felt that it was like a nice connection, but it's a little bit of an obscure one that I'm sure not everybody will agree with, I guess.
Yeah, well, hey, I mean, if the name stuck and it means something to you, so what else really matters? I don't know if you're familiar. My only familiarity with Wittgenstein comes from a novel called Wittgenstein's Mistress. Do you ever read that one?
I haven't read that one. What is that?
Oh, it's fascinating. It's sort of an experimental, weird novel, and it's about this woman who she thinks she might be the last woman on Earth, but she's not sure, and so it's sort of like the unreliable narrator. There's some, for someone like you who knows Wittgenstein a little bit better than I do, probably you could point out where it's kind of weaving into Ludwig Wittgenstein's approach to life. But anyway, that's a book rec for the people out there.
I would definitely check it out. Thank you for the suggestion.
Yeah, do so. In any case, that's where Ludwig came from. Thanks for sharing. And now we have Predibase. It became clear to you that this was the response from the community, that there was, you had something on your hands here. Is it fair to call Predibase a low-code platform?
I would say so, yeah. When I say declarative machine learning, for instance, or I talk about a configuration-based system, people really think about low-code as, oh yeah, is it a low-code thing? I say, well, sure, yeah, it is. And so that's why we started using that as a way to describe the company too, right? As a low-code AI platform now. we're doing like a bunch of things at Predibase that build on top of Ludwig, right? And make it available basically and easy to use for organizations in the cloud. So we make it possible for organizations to connect with data from databases, data warehouses, object stores, all these sort of things. We make it possible for teams of people to collaborate on developing Ludwig models and modifying configurations and lineages of configurations and comparing performance of the models trained with these configurations. And then finally to productionize them by making them available both as real-time applications through REST endpoints or for batch prediction, like on top of large amounts of data optimized for throughput instead of optimized for latency. And all of this without having to think about the complexity of provisioning an infrastructure and the machines, because it's kind of transparent to the user the way the machines are collected and used and spawned and then turned off the moment that the tasks are completed, right? That's really the core of what we're building right now.
I have a sociological question for you in the spirit of Ludwig Wittgenstein. And it is this idea of low-code platforms democratizing access to some of these technologies, I think at first blush is good. You don't want users to need to be privileged or have some sort of access to advanced upper echelons of academia in order to use some of this technology, which in the right hands is a magic wand, right? So you don't want to limit access in that way. However, should there be some kind of barrier to entry? Should someone need to have sufficient knowledge of statistics or data science in order to play with this tool in a way that we could ensure is bias-free, is ethical, et cetera?
That's a really good point. And I would say there's multiple aspects to it that I believe are important, right? On one hand, it's a matter of education, right? So I think in a world where these tools become more and more available and more valuable, I think it is starting to become very important for every developer at the very least, to be able to have basics of what's a validation set, what's a training set, what is like statistical significance, how do I evaluate performance, how do I evaluate for bias and all these things, right? So there's an education aspect. Then there is like a tooling aspect. I think tools should all provide the mechanism to, at the very least, investigate all these aspects, right? So for instance, I can tell you one of the things that we are doing, which is not like the only one possible, but for instance, we make it very, very easy for people to analyze performance of the data on slices of the data. So we have a mechanism that we call PQL. It's kind of like an extension of SQL with predictive predicates, where you can say, select this data and run predictions on this selection of the data, right? And so if you have something like this, then it's very easy if you have a data set with some sensible information, like for instance, gender information, or maybe the zip code of potential customers, things like that, to run evaluations and look at the performance on the different slices, because that is going to tell you a lot of the bias of the model. And also it's important to make it so that there's an understanding of what are the factors that impact for real the predictions of the models in order to be able to mitigate them. We in the platform have mechanisms to produce aggregate and also per data point kind of attributions of features. There's many more things that can be done, but I think all these capabilities now need to be table stakes. In particular, if we want to give these tools in the hands of people that are not trained as data scientists. The final aspect in my mind with regards to this is that I believe that in the teams that actually put machine learning in production, there should be a combination of different skill sets. So there should be data science skill sets and development and engineering skill sets. And depending on the type of company, the type of model, also other skill sets that are even outside the realm of computer science. And so then the important thing is, does the tool that I'm using support me in collaborating with people on understanding the model's performance and the model's behavior? And so I believe that the tools should support teams in that, right? You take that to heart specifically, but I think it's something that is becoming, in my mind, table stake. Like not having it will mean that the models that you put in production are not the ones that are going to do the best for your company and for your customers, right?
Who do you think ought to be at the table outside the discipline of computer science?
That's interesting. I think it really depends on the specifics, right? Just to make an example, if you're talking about house pricing, maybe urban planners should be at the table. Or maybe if you're talking about CV, curriculum, like classification or curriculum filtering, probably people from HR should be at that table. And so I think it really depends. But the important thing is, I would say at the very least, to have a multiple set of stakeholders that doesn't involve only developers, that's going to be key to have these models doing what we want them to do and not what we are just capable of analyzing the performance of, right? It's not always the case that the raw performance of accuracy on whatever, or F1 or AUC, whatever it is, aligns with the actual thing that we want the model to do and the business value that we want the model to have. And so the presence of these people will make sure is a big word. I would say will make much more likely that there's alignment.
Right. So it would just be someone with expertise, or at the very least lived experience in the area or the domain you intend to impact, right?
Absolutely, yeah.
Which is, outside the realm of AI in machine learning, it's really just the argument for building a diverse workforce, right? Having multiple perspectives at the table mean that you can serve a better swath of the population in a way that doesn't discriminate against people based on background or various other social indicators. So it's not just AI and machine learning. This is just general company building in one way, right?
I completely agree with that. It's general software building, is general company building, is just representation in society at large also.
Well, Piero, we are creeping up on optimal podcast length here, but before I let you go, I want you to speak to all the machine learning engineers out there. What can people do to look around their company, make sure they're having an impact on the ML side, and put themselves in the best position to advance in their careers?
That's an interesting question. I have a hard time making it a general statement, but I can speak to my personal experience at the very least, right? And so I would say my personal experience is what made it possible for me to do the things that I've done is constant curiosity, first of all, of any new technology, any new thing that comes up, and not being scared or threatened by whatever new technology comes up. And I think a really good example here is large language models, and actually embrace them and try to understand them deeply. So my personal asset has been always to go deep and get deep understanding of the things that I was doing and the tools that I was using. With that deep understanding, you can reuse it always across multiple projects, multiple tasks, multiple domains, multiple steps in your career. And so be curious, get really deep understanding, and apply what you learn constantly. Do little projects, even if you're not attached to it, but try to put what you learn into practice. That's what has worked for me at the very least.
That is great advice. Piero, thank you so much for being here and for walking me through all this stuff. I've loved chatting with you today.
Thank you very much for having me, Rob. This was a fun conversation.
How AI Happens is brought to you by Sama. Sama provides accurate data for ambitious AI. Specializing in image, video, and sensor data annotation and validation for machine learning algorithms in industries such as transportation, retail, e-commerce, media, medtech, robotics, and agriculture. For more information, head to sama.com.